Our presentation is on ambiguity of grammar. My name is Frank Zhang.
My name is Michael Graham.
My name is Yuan Sui.
And my name is Tyler Olson. Before we discuss the ambiguity of grammar, we must first discuss just what a context-free grammar is. A context-free grammar, or CFG, is the concrete syntax of a language that generates a string by beginning with a start symbol and then applies rules that describe how certain symbols may be replaced with other symbols of strings. A context-free grammar consists of terminal symbols, which are characters of the alphabet that appear in the strings generated by the grammar. Non-terminal symbols, which are placeholders for patterns of terminal symbols that can be generated by the non-terminal symbols. Productions, which are rules for replacing or rewriting non-terminal symbols. And then a start symbol, which is a special non-terminal symbol that appears in the initial string generated by the grammar. The language that a context-free grammar describes can also be represented with a parse tree.
Here's some definition about parse tree. Parse tree are trees labeled by symbols of a particular context-free grammar. The leaves of parse tree are labeled by a terminal. The interior nodes of parse tree are labeled by a variable, and the root of parse tree must be labeled by the start symbol. Derivation and parse tree. A derivation is a sequence of production. A derivation can be drawn as a parse tree, so different derivations may produce the same parse tree. And there are rightmost derivation and leftmost derivation. That means at each step, replace the rightmost or leftmost non-terminal to the terminals.
So here's an example of a parse tree defined by the grammar. We start off with the symbol S, which is our start symbol, and then we define that to be the productions A, B, C, and S. Since it's leftmost, we start on the left side. A can either be defined as A or B. We decide in this case to define it as A. B can be defined as B or C. We define it as B. And C can be defined as C or A, which is defined as A in this case. Then our final one is also another start symbol, which can be defined as BC. And then each of those again are defined individually as C and C, leaving our final string to be A, B, A, C, C.
So for ambiguity, grammar is ambiguous if it has more than one parse tree for some string. This can also mean that there is more than one rightmost or leftmost derivation for some string. And ambiguity is something to be aware of because it leaves the meaning of some programs ill-defined. For example, in the C language, an asterisk can either mean a multiplication or a pointer. So for the statement x asterisk y, this can either be interpreted as x times y, or that y is a pointer to some type x. Here's an example of ambiguity. So if our grammar is described as an expression, which can be expanded into either a number or an expression, an operator, and another expression, where the operator is just a series of binary operators that can either be addition, subtraction, multiplication, or division. So, for example, if we were to use the string 5 plus 10 divided by 15, there can be more than one derivation of this. In derivation 1, the expression becomes an expression, an operator, and another expression. And this one is left recursive, so then the left expression is expanded to become another expression, operator, and expression. Then the first expression becomes a number, which in this case is 5. Then the operator becomes an addition, then the next expression becomes a number, which is 10, and the operator becomes a division, and the last expression becomes a number, which is 15. So here you can see that it was a leftmost derivation, which was also left recursive, where the left side was expanded upon. In derivation 2, the expression becomes an expression, operator, and expression. Where this is a right recursive example where the right expression is expanded upon. So first, the first expression becomes just the number 5, and the operator becomes the operation of addition. And then the right expression is expanded into an expression, an operator, and expression, which is then expanded down to the number 10, the operator division, and the number 15. And you can see here that if the different layers of expansion or recursion were to be interpreted as parenthetical statements during the evaluation, which occurs after parsing, then in the first derivation it would become 5 plus 10 divided by 5, whereas in the second derivation it would become 5 plus 10 divided by 15, whereas in the second derivation it would become 10 divided by 15 plus 5. So here's a visual example of the here's a visual representation of the example I was just explaining, where you can see that in the first parse tree it is left recursive, and you expand the left expression to another expression, operator expression, which is then formed into 5 plus 10. Whereas in the right example it is right recursive, where the right expression is expanded into an expression, operator expression, which is formed into 10 divided by 15.
Since ambiguity can be a problem, when defining a language, you can just make the language unambiguous. To do this, for this example, the expression can either be rewritten as a number or a number operator expression. You'll see later that this forces the language to expand to the right, or is right recursive. So we'll start with an expression, and we're trying to get to this string 5 plus 10 divided by 15. So the expression is rewritten as a number operator expression, and then following the leftmost derivation, the number becomes a 5, the operator becomes an addition, and then the expression becomes another number operator expression. The number is rewritten as 10, the operator is rewritten as a division, and then finally the last expression is rewritten as a number, and then 15. This is a parse tree as a visual representation of the derivation. And once again, you can see that this tree is expanding to the right, meaning that this grammar forces right recursion, and this is an attempt to deal with ambiguity. This particular string, 5 plus 10 divided by 15, has one parse tree for it.
Thanks.
Cool.